So basically the unit is geometric optics, and this is also known as mirrors and lenses. And basically what we're going to do first is review, good morning, plane mirrors, and then we're going to talk about the images produced by concave mirrors, and then we're going to talk about the images produced by convex mirrors, and then we'll be about half done. And then we're going to go on and talk about the images produced by converging lenses, and then by diverging lenses. So basically, your goal is to be able to draw light ray diagrams showing how the images are produced from all of these optical devices. How can ray diagrams be used to determine the size, type, and location of images produced by mirrors and lenses? So we'll start by a quick review of plane mirrors. If I have a flat mirror, and let's say this side right on here is the smooth side, and let's say I have a person out in front striking a pose. Now, instead of drawing a person like this, hey, how you doing, like this, and this is the head of the person, and this is the feet of the person, since we're going to have to draw so many objects out in front of the mirror, we're going to save time, and instead of drawing a little person like this, instead of drawing that person, we're just going to draw an arrow, and the arrow is like the little person striking a pose. And this is like the head of the object, and this is like the feet of the object. So this is our object. And today I'll be drawing the light rays using red. So anytime I draw in red, you know that that's light. Now I know that the image produced by a plane mirror is always the same size and the same distance behind the mirror. So if this is my object, I know like right here, that's going to be my image and it should be the same size. And usually you don't draw the image until the end, but I'm going to just kind of cheat because it'll help me draw my rays correctly. Now, light shines down from maybe a ceiling light or maybe outside light and shines on the object, and then diffused reflects off the object and scatters in all different directions. So when the light shines down from like the ceiling light, it reflects off the object and then it goes in all different directions. And basically, we're not going to draw all the light rays reflected off the object. We're only going to show some key light rays that reflected off the object. So instead of showing all these light rays, I'm not even going to show the light that actually shine upon the object. And I'm not going to show all these rays reflecting off the object. I'm just going to show a few crucial key rays. So let me go back and get rid of these light rays. And let's say I draw a light ray going up this way, and it's going to hit the mirror, and when it hits the mirror, it's going to obey the law of reflection, and it's going to go up that way. I could draw the normal line if I want it, and label my little angle of incidence and my little angle of reflection, but I'm not going to be doing that all the time. And notice, I know that when I extend that backwards, when I extend it backwards, it should go back to the head of my image. So when I extend this back, it should go back to the head of my image. And then I'm going to take another light ray, and that light ray reflects off the mirror, goes up that way. And once again, that light ray would also obey the law of reflection. And notice the two light rays that bounced off the mirror, this one right here, and this one right here, are they spreading apart or are they coming together? They're spreading apart. And the fancy-dancy way of saying they're spreading apart is they're diverging. And anytime you have diverging rays, they're never going to come together and form a real image anywhere. However, if somebody was looking and catching those reflected light rays, their eye would be faked out, and where would their eye think that those light rays came from? Well, if you extend those bounced off rays, those reflected rays back, those light rays appear to be coming from here. A person's eye catching these light rays, their eye and their brain would be faked out, and they would think that that light actually came from the light really came from right here, the head of the object. But the person, up here looking in the mirror, they would think the light came from right there. And we could play the same game for the feet, and we could say, hey, look, if some light left the person's feet and obeyed the law of reflection, and maybe another light ray, once again, are these rays converging, coming together, or diverging, going apart? Converging, coming, diverging. And if they're diverging, you extend them backwards. And where they intersect, that's the location of the image that gets produced. So this here is the image. If it's drawn perfectly, it's the same size as the object. It's upright. It's not upside down, it's upright. Is there actually any light going behind the plane mirror? Is there any light that actually goes back here? No, all the light is just bouncing off the mirror and going this way, bouncing off the mirror and going this way. There really isn't any light behind the mirror. So what kind of an image do you see when you look into a plane mirror? Real or virtual? Virtual. So this is a same size, upright, virtual image. Also, however far the object is out in front of the mirror, that's called d sub o, the object distance. That's how far the image is seen inside the mirror, d sub I. D sub o equals d sub I. So, if this right here is 3 feet out in front of the mirror, then the head would be 3 feet into the mirror. If the feet are 3 feet out in front of the mirror, the feet are 3 feet into the mirror here. Sometimes you'll be asked to identify the virtual image produced by a plane mirror. So let me give you an example. Let's say, here's the mirror again. And let's say the object this time is leaning forward like this. So that's our object. That object could be anything, by the way. It could be a coin, it could be a person leaning forward, it could be anything. It's just the thing that's out in front of the mirror. And whether it's giving off its own light, or whether it's diffuse reflecting light from the ceiling, if you draw a ray diagram to locate the image, well, we know however far this is, then the image head is going to be the same distance over here. And we know, however far the feet of the object are away from the mirror, that's got to be the same over here. I draw this image over here with a dotted line to remind myself there really isn't any light back there. That's where the eye gets faked out. And my picture is not perfect, but those distances on both sides should be the same. So this is the image.